All right. What other questions did we come across on the homework? Three. Number 3. Here we go. Number 3. All right, Garvey. We're going to change Sam to Garvey. Sound good? Garvey has 34 coins that are nickels and pennies. Woo! He has $1.06 total. How many coins of each type does he have? Nickels, pennies, right? Yo.
16 pennies and 18 nickels.
Sounds good. Let's 16 and what? 16 pennies and what?
18.
18 nickels. That's what the gallery says. Let's see. Let's see if we can get there. Let's see if we can get there. We can do this. All right. So I'm going to use N. I'm going to use P. Sound good for nickels and pennies? Yo, cupcake. Thank you for a little. Let's see. But he is not here. Someone told me he didn't get off the bus again. Thanks so much. So we're using P and N. Guard, are you still with me in this adventure?
C.
C? Okay, we're not going to use C for coin. Alright. So P plus N. How many coins do I have total, Garvey?
34.
34. So I reach in my pocket, pull them out, saying, oh, look, pennies and nickels. And I count 1, 2, 3, 4, 5. And there happens to be 34 of them. So what else? Alright. So how much is a penny worth as far as a dollar would go? 1 cent. So a penny is 0.01. Yes? And a nickel is? 0.05. And how much money do I have total? $1.06. Okay, so what skill did we learn? Yeah, and do I have to multiply 100 on the very top one? No. So I'm just going to multiply by 100. Christian, if I multiply everything in this row by 100, what does it do to the decimal? Move it right, move it left. It moves to the right twice. Good. So if I multiply by 10, it would move the decimal once. If I multiply by 100, it moves it twice. Multiply by 1,000, 3 times it would move it. So this moves the decimal here, here, and here. So that gives me 1p. Is that the same thing as p?
Yeah.
Okay. And 5n equals 106. Okay. So I don't need to have the 1 there. So I'll just write it like this now. And let's bring this equation down right here. All right. So who's next on our agenda? Megan. Do you feel right now we could be set up to add these equations together, perhaps by multiplying by a negative or a negative and a number? That if I were to add them together, either the n would go away or the p? P? What do you want to multiply by 100? Or, excuse me, by negative? Top or bottom? 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 Okay. Multiply the whole bottom by negative 1. So that gives me, so I'm going to rewrite this one right here. P plus 5n equals 106. And then I have negative p minus n, and that's 1n, equals negative 34. Cool. TJ,
Yes.
what falls out if I add the 2 red equations together now?
You got 4n.
Okay, so that's gone, right?
Yeah.
And that's what?
4n.
4n. And then 106 minus 34.
82.
82?
72.
72. Divide by 4. And so, let's see, 4 goes into 7 once, 3 left over, 4 goes into 32 18 times. So I have 18 nickels, 18 nickels. Sweet! Of those 18 nickels, I have P plus 18 equals 34. So if I subtract 18 from both sides, I wind up with 16 pennies. Good deal. Good job, Gage.
Thank you.
Yeah, buddy. So again, it's just going through, manipulating it. Don't be afraid of it. nothing will break if you try something to a problem. If you make a problem turn out much harder, then you might have multiplied or divided by the wrong thing. Okay? All right, what other questions might we have come across? Yeah?
Can we do 2?
Number 2? Absolutely. Number 2. All right. So Stephen, number 2 has Tina has 40 quarters and nickels. So what 2 letters do you think I should use? N and Q? We're going to use quarters, nickels, Q and N. Okay? Stephen, how many coins do I have? If I just reach in my pocket and like, oh, look, it's quarters and nickels. How many of them are there? What's that?
We get 44.
Tina has 40 quarters and nickels, right? So Tina reaches in her pocket or looks in her purse, sitting on her dresser, I don't know where it's at. Realizes, oh my gosh, they're all quarters and nickels, and there happens to be 40 coins in all. Okay? So, Bo, how much is a quarter worth? Well, this would be 0.5n, yes. How much is the quarter worth, though? 25? So 0.25, right? And how much money does Tina happen to have with that? $5.60. Okay. Bo, what do you think I should do to that second equation to get rid of those decimals? If you're going to be right, we're going to eventually subtract, but if I subtract them right now, nothing's going to fall out, meaning the N or the Q. So I don't like the decimal, though. I don't like 0.25. I don't like that should have been 0.05, excuse me. So what should I multiply everything by to move the decimal 2 places to the right? Matt, turn around and tell them. So if I multiply by 10, the decimal moves 1 place right. If I multiply it by 100, it moves it 2 places. So I'm going to bring this one down here so it's easier for us to keep track of. And then this one will come right here. So I get 25Q plus 5N equals 560. Okay? George, if I add these equations together right now, is something going to fall out? So if I go Q plus 25Q, is Q gone then? No. What about N and 5N? Is N gone then if I add these together? No. What would you like to get rid of, Q or N? And I'm going to give you this choice. I either have to multiply by 25 or I have to multiply by 5. So what's easier to multiply by? 5, okay? So if I multiply this entire, if I multiply this whole entire equation, get out of here. If I multiply this whole equation right here by -5, so here, here, and here. So this is then going to result in -5Q. If I add those together, does the Q go away? Right down? No, not yet. And then -5 times n is -5n. And then -5 times 4 is -20. -5 times 40 is -200. So George, if I add those 2 equations together right now, what letters bye-bye? N. Good. Mackenzie, that and that cancel out. What does 25Q minus 5Q give me? 20Q. And then 560 minus 200 is how much would you feel? 0 minus 0 is 0. 6 minus 0 is 6. 5 minus 2, 360. And then what do I do to get Q by itself? Divide by 2, right? So Q is equal to, let's see, 20 goes into 36 once, leaving you 16. Add the 0. 20 goes into 168 times. So I have 18 quarters. How many total coins did I start with, Kieran? How many total coins did this person start with? 5?
Whoa, what?
How many coins did we start with? Read it.
I was. Start yelling at me and stuff.
That's just pressure. 2? 2 coins?
40.
You're right saying you have quarters and a quarter nickel is my 2 coins, but how many total? 40? 40?
3.
Right? You with me? Still? Okay, so I have 40 total coins. 18 of them, 18, still with you, Karen? 18 of those 40 coins happen to be what? Quarters. So 18 quarters plus a certain amount of nickels will give me 40. What number is it? How many nickels? Borrow, 10, 2, 3 minus 1. I have 22 nickels, 18 quarters to give me a total of 40 coins. And if I have 18 quarters and 22 nickels, that gives me $5.60. Sweet. Anything else we have to go over?
Yes.
Go ahead. Last one. Speak.
I would have to say,
3, 2.
did we do number 5?
Doing it.
It's not. Number 5.
All right, Tristan, coming to you. We're selling tickets at number 5.
Really?
Yeah. It's gonna be exciting. Gonna be exciting. Tickets for homecoming dance cost $20 for a single ticket, meaning you're not paying for your date, or $35 if you and your date are going to homecoming. So $20 for a single, $35 for a couple. So Tristan, if 20 for a single, 35 for a couple, what letter should I use?
Can I borrow a pair of scissors?
What are you possibly working on that needs scissors? We're not in geometry.
Just need
Take a little off the top.
Cutting somebody's hair.
Yeah, I need it.
Cutting your stitches out of your hand.
Catch.
Let's scare him. Catch.
Oh.
Ooh, he's got tricks. They go back in the drawer that's open when they're done. All right, Tristan. S and C. C for couple. S for single. Yes.
No, S is for sadness because you're alone.
Okay, I'll go with that. Sadness and cutie or something. I don't know. How many total tickets did we sell? What does our word problem tell us?
Little, it just says the amount of cash and the people. It doesn't say how many tickets.
Okay, so how many people attended?
Oh, 128.
128. So some combination, whether it was singles or couples or sadness and cuteness or however we want to call it, there's 128 people on our dance, and we're amazed that no one snuck in. All right, a single ticket costs how much, Tristan?
A single ticket costs $20.
Okay. And a couple?
A couple costs $35.
$35. And how much money did we have to make at this dance?
2,200.
Okay. All right, thank you. Ray, is there any reason I need to move any decimals on this problem? No. Okay, I like that. The reason we don't have any decimals to move is I'm not dealing with a coin amount and a dollar amount. Okay? Ray, if I add these two equations together right now, do any of the letters go bye-bye? No. Would you like to multiply by a negative 20 or a negative 35? Negative 20? Okay. I'm going to take that whole top equation, multiply by negative 20. Distribute it. I'm going to bring this right down here. So I get negative 20s minus 20c equals negative 128 times 20? How much? 2,560. Yeah. Is that right? Is it negative? Yeah, it's negative. Someone double check that. Negative 20 times 128. Is it? Is it 2560?
Here.
Someone calculate.
It is 2,560. Yeah, you're right.
Oh, it is? Okay. And then I'm going to bring this one straight down. So I get 20s plus 35c is equal to 2280. Something's not going to work right here. That cancels with that, yes?
Yes.
If I add these together, I get positive 15c. What's negative 2560 plus 2280? How much?
200.
Negative
Negative 280.
negative 2 what?
Negative 280.
Negative 28, really?
Yeah.
You should probably work it out.
You guys have the technology, though.
It's negative 280.
It doesn't come out evenly.
It's negative, I know that. What does it come out to?
Negative 280.
I don't know.
Negative 280?
It came out as a decimal, so I stopped.
Okay. So negative 2560, still with me? Actually, just do this. Go 22.
Negative 280 it is.
Negative 280, okay. Oh, no. Uh-oh.
I'm afraid.
This isn't going to work. Hey, why is this not going to work?
Negative money.
Negative money. Yeah, we're not the government. And we got a negative answer, so you know what happened on this problem?
No solution?
Yeah, there's not going to be a solution to it.
What? I spent like 30 minutes on that.
Well, we do get a solution, but we get the C is negative.
Yeah.
And that wouldn't make sense that I sold negative tickets.
Yeah, because relationship.
All I'm asking is that please tell me there isn't going to be anything like this on the
Well, I'm going to make sure that they work out on the test. I
Okay.
hadn't worked these
And
out.
that's perfect, because other than, because I was working on this problem, and I'm like, why can't I get this problem to be like,
It happens.
not a negative?
I'm so sorry. I didn't mean that for that down. Every now and then every now and then a mistake will take place, right? All right. So we're gonna take a break from word problems, and I know most of you are gonna cry yourselves to sleep taking a break from word problems. Is that okay? But we're gonna start graphing again, but we're gonna graph again with inequalities. Sophia, coming to you first. So, let's say I had this. Sophia, you ready? So this is going to be graphed the same way as y equals 3x plus 2. Is that okay if I say that? So I'll go ahead and let me make my xy axis in blue. So what would my y-intercept be? What would you feel? Positive 2. So right here I'm going to go up 2, put a dot, and then my slope is what? Up 3 and to the right 1. Good. So from this point I'm going to go up 3 and over 1. Okay? Now Sophia, is it solid or dotted? Why? Yeah, good. So it's a dotted line. This means it has to be dotted because we don't have an equal to. So it's a dotted line like this. Still with me? Now when we had originally done these, we picked a test point, and a lot of times the test point is 0, 0, right? And so on this particular problem, if I were to pick 0, 0 and plug it back into original, 0, 0. And the reason I'm picking 0, 0 is 0, 0 is definitely on one side of this line. So if I put 0, 0 and plug it in, I get 0 is greater than 3 times 0 plus 2. So 0 is greater than 2. Is that true or false? Is 0 greater than 2? No, it's false. So what that would do is that's going to tell us to shade all up here, the opposite side. And I'm not going to shade it yet. Okay? So what I'm going to change up on this, Casey, coming to you, is then I'm going to have this also graphed. And this is set up in a way that the cover method is going to work. You still with me on the cover method if I say that? So 2 times x is equal to 6. So what does x have to equal? 3. All right. Now Casey, negative 3 times y equals 6. What does y have to equal? If negative 3 times something gives me 6. Negative 2. Sweet. And would you feel this would be a dotted or a solid line? Solid line? Definitely a solid line. So eventually, these two are going to intersect each other. Looks like there.
That's
Yeah.
negative 20.
That's way down yonder. All right, so now here's what we're kind of aiming at on this problem. I have, with my graphs, let's say I had like this. I'd have one region here, one region here, one region here, and one region here. So I know my graph doesn't look exactly like that, but I have a region that's in this little tiny area here. I have a region down here. I have a region up here, and then I have this region down here. Okay? Does it make sense how I just said that? So let me get rid of this mess right here. Okay? So now, 0, 0 is still a pretty good test point. This is still a pretty good test point. So when I plug 0, 0 in, I get false. So right now, that tells me that up here is going to be shaded, but it's up here or it's down in this little region. So let's take 0, 0 and plug it into this one over here. So this gives me 2 times 0 minus 3 times 0 is less than or equal to 6. Is 0 less than or equal to 6?
Yes.
That's true. Okay? So, I'm going to shade the opposite side of the green line, but the same side of the black line. So I'm going to shade this region of the black and this region of the green. So that means that all of this region is shaded. Okay? We'll probably do another one, don't you think?
Wait, so then what would we have for
Something similar to this.
Is it like 8, 9, and 10 on?
Yeah. Let me clear this. Can I clear?
Yes,
All right. Gabe, coming to you. Gabe, coming to you. Ready? All right, Gabe, here we go. XY axis. The red equation looks like I could use the cover method. Does that make sense if I choose that? Okay? Okay, so 3 times what number would give me 12? 4. So I have 1, 2, 3, and 4. And then 2 times what number would give me 12? 6. So I got 1, 2, 3, 4, 5, and 6. Okay? Do you think this should be solid or dotted? Dotted because it doesn't have the equal sign. So this indicates it's going to be dotted. Okay, a couple of you are off task. Okay? This is a dotted line, looks like this. Okay? Andrew.
Yeah.
The second equation is not set up to do the cover method because it's y equals. So what is the y-intercept of that one? 1. So I'm going to put a 1 right here. And then how am I going to find the second point? Up 3 and over 5. So from this point, I'm going to go up 3 and over 5. And is that going to be a solid or a dotted line? Solid line because it has that, right? Cool. Okay, now, Ashley, can I pick 0, 0 as a test point? Do either of the lines go right through 0, 0? No. So right now, if I got true and true on my two equations, that would mean I would shade down in here. Okay? But it might not be true and true. It might be true and false, it might be false and true, or it might be false and false. So if this gives me true and true, we're done. And that's just this region down here gets shaded. If it gives me a false and false, I'm going to shade the region up here because the region up here would give me a true and true. If it gives me a true and a false, it would be over in this region or over in this region that we'd have to shade. So we might have to pick another test point. But I'm going to pick 0, 0 for right now. You still with me in this adventure? So if I take 0, 0 and plug it into this top equation, I get 3 times 0 plus 2 times 0 is greater than 12. Is 0 greater than 12? No. There's no such thing as negative 0. 0 is not, it's a signless number. Okay, so that gives me false. So right now, that tells me that I am not going to shade this region down here. Okay, that does. If I get it, find another false, I might have to shade up here, but we don't know yet. Okay, so on my second one, I'm going to plug 0, 0 in. So I get 0 is less than or equal to 3/5 times 0 plus 1. 0 is less than or equal. What's 3/5 times 0? 0. And 0 plus 1 is 1. Is 0 less than 1? Yeah. Uh-oh, that gives me a true. So this region down here gave me a false true. That means this region up here gave me a true false. Okay? If I plugged it in. I want to find the true true. So I'm going to pick another test point. So I'm going to pick something that stays on the line. I'm not going to pick anything up here because that's where I have true false. So I'm going to pick way over here. Like, what would happen if I were to pick the point 10, 0? Is that, do you feel that, everyone, does that seem that it would be way over on one side? Okay. The 10 represents what value? X or Y? X. So I have X and Y. So I'm going to take this, I'm going to plug it into the original. So I have 3 times 10 plus 2 times Y, which is 0. 3 times 10 is? 30. 2 times 0 is 0. Is 30 greater than 12? It gives me my first true. Let's take the 10, 0, plug it into the other one. So I get 0 is less than or equal to 3/5 times 10 plus 1. That's, 30 over 5, which is 6. 6 plus 1. Is 0 less than or equal to 7? That's also true. So that tells me that this region right here, in between those lines, is where my solution will fall. Okay. Shall we try one more?
Yes.
No. It saddens me when the person that hasn't done homework for the last 6 weeks says no.
I've done my homework.
They've been in school for
Yeah,
6
okay.
months.
So I exaggerate a little bit. All right. Clearing this. Let's try one more. Angelo.
Oh, yeah.
Yeah, baby. I get x is greater than or equal to 3, and then I get 2x minus 6y is less than or equal to 24. Still with me? Okay. So I'm going to make my xy axis. All right, Angelo, you ready? I gave you the challenge. This is indeed a straight line, but it's a special kind of straight line. Does it go up and down or right and left? Is it vertical or is it horizontal? I'm going to give you a little clue. X equals 3 is 1, 2, 3. Angelo, x equals 3 goes right there.
Yeah.
So in order for that 3 to work, does it have to be a vertical line through 3 or a horizontal line? Vertical. And is it solid or dotted? solid because it has the line under it. So we have, this is our first one. Okay? Reese, cover method looks like it might work up here.
All right.
Cover method looks like it'll work on this problem right here.
Yes.
Okay? So 2 times x equals 24. So what does x equal to?
7.
2 times x. 2 times what number gives me 24? 2 times 7 is 14. 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why is there people packing up? We still got like 9 minutes left. All right? Reese, still picking on you. Negative 6 times what number gives me 24? Negative 6 times what number gives me 24? 4.
No.
What?
Negative 6 times what number gives me 24?
Negative 4?
Negative 4. Solid or dotted line?
Solid.
Solid. That look okay? All right. Gauge. Is 0, 0 an okay test point up here? Meaning, do either of the lines go right through 0, 0? No. So it's a great test point. So if this region right here, this region that's right here, is true, true, then we shade here. If it's false, false, then I'm going to shade the region right over here. Okay? So let's see which one works. So I just have an x, and that's an x and a y. So I'm going to use just the 0 on the x. So is 0 greater than or equal to 3? That's false. Okay, let's see if the other one gives me another false. So then I have 2 times 0 minus 6 times 0 is less than or equal to 24. So 0 is less than or equal to 24.
That's true.
False. Or less than, yes, that's true.
Okay,
False.
so this region gave me false, true. That means this region down here gives me true, false. Okay, so that's not going to work as well for us. Let's pick another point. Let's pick, I don't know, 1, 2, 3, 4, 5. 5 comma 0 is definitely up in this region. Does everyone agree? 5 comma 0 is definitely up here. So let's plug our value in. So I get 5 is greater than or equal to 3.
Yeah, true.
True. Okay, let's plug it in here. 2 times 5 minus 6 times 0 is less than or equal to 24. So 10 is less than or equal to 24. True. So that gives me a true. It gives me a true. Whoa, hey. Hip hop, a hip hop.
Hey now.
Get your game on. So this whole region here is true, true. So I'm going to shade here. And you could be that one that, you know, during the test you hear this. Meanwhile, you're 7 or 8 questions into it, and the person next to you is. And then usually at about this point, you start realizing kids are looking around, going, "Who in the heck is this?" And then you get the person going, "Do you have an eraser?" Not quite that big, and that's when they have the eraser that's down to the nub, so their metal drags across the paper on the desk, and you're like, "Yeah." All right, ladies and gentlemen. So tonight's homework is worksheet number 5, and it's page 132 in your book, 133 in your book, and I have a couple of extras here I made copies of. If you need a copy. Now, if you need a copy, come on up. Guys and girls, I need you to head over to the Bare Necessities in the next day or 2 or 3 and get the new book for second semester. It's $5. It looks like a 3-ring binder. It'll work best. Okay? It doesn't have the spiral in
Is
it.
that the same packet as is that, how many packets are we?
Oh, I
Oh, I don't have this.
Anybody else need one? So guys and girls, thanks for being